In this video, I'm going to talk about trig functions. In our previous video, we started with trig function. We look at the basis of trig function, and particularly we look at the unit circle, how to use the unit circle to solve trig functions. So in this particular video, we are going to continue by solving an example to see how to use the unit circle to solve trig functions, right? So our first example is we are going to solve 2 cos of t equal to root 3. So there's really not a whole lot to do in solving this kind of trig equations. What we need to do first is to get the trig function on one side by itself. Then we go ahead and solve it. So to do this, all that we need to do is to divide both sides by 2. So we have our 2 cos of t being equal to root 3. So dividing both sides, we should get cos of t equal to root 3 on 2, right? So we are looking for all the values of t for which cosine will have the value of root 3 on 2. So now let's look at the following unit circle, right? Our unit circle right here. So from quick inspection right here, we can see that theta or t here is equal to pi on 6. You can see from here. So where do we find that? We know that the cos or the cosine is on the x-axis. So we are looking for the s coordinate. And where do we get that? So let's look at this right here. So here we have pi on 3, pi on 4, pi on 6, right? So that's where we got our root 3 on 2. We are just looking at the x-axis because we are dealing with cos or we are dealing with cosine. That's why we took the pi root 3 on 2, right? Now, however, as we have shown in the unit circle, there's another angle which is also supposed to be a solution, right? So we need to determine what this angle is. Now, when we look for these angles, we typically want a positive angle that lie between 0 to 2 pi, right? Now, this angle will not be the only possibility of a cos, right? But we typically look for angles that meet these conditions. Now, to find this angle for this problem, all we need to do is to use the little geometry that we've learned previously in our previous video, right? So the angle in the first quadrant, which is right here, this is our first quadrant, right? And it's a positive quadrant as well. The angle in the first quadrant makes an angle of pi on 6 with the positive x-axis. Right? So then we must the angle in the fourth quadrant, right? So we have 2 options to choose from. We could use negative pi on 6. But again, it is more common to use the positive angles as we talked about in our previous videos. Now, to get a positive angle, all we need to do or all that we need to use is the fact that the angle is pi on 6 with a positive x-axis, right? And the positive angle will be t equal to 2 pi minus pi on 6. And when you subtract that, you should get t should be equal to 11 pi on 6, right? 11 pi on 6 radian. Now, one way to remember how to use the positive form of the second angle is to think of making one full revolution from the positive x-axis, which is the 2 pi, right? And then backing off. Backing off means subtracting it, right? So making one revolution, then backing off by subtracting whatever the first radian that we have, the starting radian that we have, we just subtracted from that 2 pi. Then we get the next radian, right? So here again, we are not done with this problem. As we discussed in our previous videos, the second angle has shown there are many ways to write any given angle on the unit circle. Now, sometimes it will be like negative pi on 6 that we want for the solution, and sometimes we want both or neither of them, right? Listed angles. Now therefore, since there isn't anything like in this problem to tell us which is the correct solution, all that we need to list all the positive solutions that we can do, right? So this is very easy to do. So we can record from our previous video that pi on 6 plus 2 pi n, where we know that n can be equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, going and goes on and on, right? To represent all the positive angles that can end at the same location on the unit circle, that is the angle ends at pi on 6. Now remember that this says is that we start at pi on 6, right? We start from pi on 6, then we rotate around the counterclockwise direction, which is the n is positive, right? Or clockwise direction, which n is negative, right? So you start from pi on 6, then you rotate in a counterclockwise direction where n is positive, right? Where n is positive, and when you rotate around the clockwise direction, right, starting from pi on 6, then clockwise direction we have n to be negative, right? So that's what we do now. So the same thing can be done for the second solution as well. So altogether, the complete solution for this problem is gonna be pi on 6 plus 2 pi n, right? Where we said the n here is 0, plus or minus 1, plus or minus 2, plus or minus 3, goes and goes on. And the second one is gonna be 11 pi on 6 plus 2 pi n, where we know our n is 0, plus or minus 1, plus or minus 2, and plus or minus 3. So in our final answer, that we can get negative pi on 6 by using n equal to -1 in the second solution, right? So it's very, very simple to do. It's very simple to do. So if they don't state solution, maybe the next two, so give us maybe 3 solution, you can just list them in this kind of form. Just find the first solution, second solution, then you can just state it in this form to tell them that we have a lot of solutions to give, but this is how you can just summarize them, right? So this is very simple, and thank you for watching, and I will see you in my next video where we solve the second example.